Hey y'all, we're going to take a look at the FRAPPY for Chapter 6, and this goes over several ideas that are going to show up on the Chapter 6 test, so I think it'd be helpful to take a look at it. Buckley Farms produces homemade potato chips that it sells in bags labeled 16 ounces. The total weight of each bag follows an approximately normal distribution, with a mean of 16.15 ounces and a standard deviation of 0.12 ounce. All right, so I've kind of highlighted some important information as we were reading. If you randomly select one bag of these chips, what's the probability that the total weight is less than 16 ounces? So starting with A, this is actually just your typical normal curve situation. If I'm trying to find a probability and I know that a normal curve models the scenario, then I am going to draw my normal curve. Remember to put the n with the mean and the standard deviation. And then we have the mean in the middle. If I'm looking for a probability, that's essentially the same thing as asking for the area under the curve. So I'm just choosing one bag out of the whole population, and I want to know what the probability is that the weight of the bag is less than 16 ounces. So remember that this picture, this sketch, is your work for this problem. You could find a z-score, and then you could use the normal table. So this is how you would find the z-score if you wanted to find the z-score, and then you would use the normal table to find the area to the left. Or you could go over to your calculator, and in probability or statistics, you go to distributions, and this would be a normal CDF question. So our lower bound is negative infinity, that's correct. Our upper bound is 16. Our mean was 16.15, and our standard deviation was 0.12. So I see that the area to the left is 1056. So this area right here is 0.1056. That is the probability that one bag is less than 16 ounces. That is really important because we need it for Part B. Part B says, if you randomly selected 10 bags of these chips, what's the probability that at least 2 of the bags will have a total weight less than 16 ounces? Okay, so first of all, I'm noticing that I have a fixed number of trials here. I'm going to be selecting 10 bags of chips, and I'm looking for exactly 2. So the wording of this is making me feel binomial. And it's probably a binomial PDF situation. But before I actually use a binomial formula or use binomial PDF, we must check conditions. So is this binary? Yes, because it's either going to be less than 16 ounces or more, okay? Or I mean, it could be equal to. I'm going to write 16 or greater. So it is binary. Is it independent? They don't really tell us. So we are going to have to assume, since I'm choosing 10 bags, 10 is less than 0.10 of all the bags produced. So the 10% condition is met, so that means that it is independent. N is the number of trials, in this case it's 10. And then S is the same probability of success, which in this case is what we got in our last question, which is 0.1056. Okay, so bend is met. So that means that I can actually find this probability. Remember, there are 2 ways to do this. You could use the formula, which would be 10 choose, and I think we wanted 2. Yeah, so it's at exactly 2. So 10 choose 2, and I would have the probability of success raised to the 2nd power, and the probability of failure raised to the 8th power, because if I have 2 successes, that means I have 8 failures. And just because the subtraction was like not easy to do in my head immediately. I just wrote 1 minus that to show my like failure probability. So you can either do this or you could use binomial PDF. And if you decide to use that as your work, please, please, please label your numbers. So you can type it in first if you want to, but make sure that you label it. So I'm actually going to do that. I'm going to go to binomial PDF. It's a distribution, and there it is. We have 10 trials. This was 0.1056, and I wanted 2 successes. So 0.205, so 20.5%. So there's a 20.5% chance that exactly 2 of the 10 bags that I pick are going to have a mean less than 16 ounces. Sorry, a weight of less than 16 ounces. All right, C gets interesting. And I think I'm going to type just because it's will be neater that way. Buckley ships its chips in boxes that contain 6 bags. The empty boxes have a mean weight of 10 ounces and a standard deviation of 0.05 ounce. Calculate the mean and standard deviation of the total weight of a box containing 6 bags of chips. Okay, so let's suppose that C is the weight of a bag of chips and B is the weight of the box. Okay, these are random variables because they vary depending on, you know, which particular bag of chips that you got. Manufacturing is not like 100% accurate where it'd be the same every time. So what I'm essentially wanting to do is find their total. So I'm going to define a new variable as T is C plus B. This is mostly for my sake to keep track of my variables. If I'm trying to find the mean of T, I can just add these up. Now, I actually need to go back up to the total for a second. The way it looks right now, it's like I have 1 bag of chips plus the weight of the box. There are actually 6 bags of chips and then the box. So when we do this, we're going to be adding the mean 6 times, which you can literally just write it 6 times like this if you want to, or you could do 16.15 times 6. And then I need to add the box, which the box had a mean weight of 10. This is going to give me 106.9. And there we go. And this is going to be ounces because all of these were ounces as well. So I just added a bunch of ounces together. Now, standard deviation is trickier because I cannot just add their standard deviations together. You might remember that I need to add their standard deviation squared, which means I'm adding their variances. So the chips had this standard deviation. And okay, I'm gonna have to just write this one because there's too many subscripts and things. The chips were 0.12. So this is the variance of 1 bag of chips. Part of why I'm writing it all the way out like this is because I want to emphasize that I'm not doing 6 times the standard deviation. I'm doing like 6 times the variance. And then I'm actually going to add the variance of the box as well. So that was the variance of the box. To find the standard deviation, I actually need to take the square root of all of that. So essentially, I have the square root of 6 times 0.12 squared. Okay, so that was like 0.12 plus 0.12 plus 0.12 plus 0.12, yeah, squared, and 6 times. And then I need to add to it the variance of the other one of the box. And then I take the square root of the whole thing and I get 0.298. And I'm realizing that I got a different answer than the back of the book. And I'm honestly not sure why. I think that maybe the back of the book is wrong. Because I double checked it. So I got 0.298 ounces. So that is part C. I have the mean and I have the standard deviation right here. Part D says Buckley Farms decides to increase the mean weight of each bag so that only 5% of the bags have weights that are less than 16 ounces. Assume that the standard deviation remains 0.12 ounce. What mean weight should Buckley Farms use? Okay, this is interesting, and it's actually not what I was anticipating. For some reason, I was thinking this would be a question about like the weight of the box together, and it basically like it's really common on AP test and also on my test to have to take the mean and the standard deviation from part C and use that in a new scenario. But that's not what's happening here. So let's actually draw a picture of what they're saying. I think that that'll help us make sense of it. So for part D, this is still normally distributed. They want 5% of their bags to be less than 16. So they want that to be 5%. They still want the standard deviation to be 0.12. What we're looking for is the mean. They're saying, like, what does the new mean have to be so that this would be true? So since we have the percent, this is going to be an inverse normal situation. And it's interesting because well, let's look at it, remind ourselves what inverse normal looks like. It's in distributions again, and then it's inverse normal. Okay, so the area is 0.05. I don't know what the mean is, and so I'm just going to leave the mean and the standard deviation as 0 and 1, because what this is going to do is tell me what the z-score would be if my area was 5%. So I hit OK. So my z-score is negative 1.645. Okay, so z is going to be negative 1.645. And I'm going to just have to like skip past this here, or maybe I can shrink it. Come on. I'm just going to make that smaller so we can move it off to the side. Okay. If my z-score is this, and I know the z-score formula to be value minus the mean over standard deviation, I can actually solve for the mean just using algebra. So I'm going to multiply 0.12 on both sides. And then I'm going to subtract 16. I'm just leaving it like this for now. Okay, now notice that this is actually going to give me negative mu. So I'm going to need to change the sign when I get an answer. So I have negative 1.645 times 0.12 minus 16. So 16, and then again, I'm going to have to, change the sign on that. So 16.1974 is what the new mean has to be in order for 5% of the randomly chosen bags to have a weight less than 16. So I basically was working backwards, and I had to use inverse normal to find the z-score, and then I had to use the z-score formula to solve for a mean.